Alright, cool guys. So today is kind of cool because Algebra 2 is known for logarithms, and this is a topic that people have never heard of until they get to this course. And for a lot of people it's a real stumper because it's such a different concept and that they don't know like why it's being used or where it came from. So that's what I'm going to try to do is introduce this for you, and hopefully it won't seem too scary. So when you're doing it in class for, 2 months or however long you're going to do this, you'll be able to get through it with the basic understanding, okay? So what is a logarithm? What on earth could this be used for? You are going to see logs probably in chemistry as well as Algebra 2. If you in chemistry ever studied like a pH level, then or maybe it'll be AP Chem, I don't know, but if you did some pH stuff, that is definitely based on logarithms. And another thing that logs are used for is people that I don't remember their profession, but people that are measuring earthquakes. And what are those called? Like a size, they're called like they're called like seismographs or something. But whoever the people, the scientists are that use it, this is also a logarithmic function that's used. And that's your real world. This does happen to people in the real world. Sciencey people is what you're learning. But it could help you a lot as well, because what you're going to see is that exponential and logarithmic functions go hand in hand. So it's like you have to know how to do exponents to do logs and vice versa. And these are actually inverse functions. And I can talk to you guys more about that in tutorials if you're coming to tutorials. But that word inverse is going to be thrown around a lot next year. And an inverse relationship just means that if you took one graph, switched the x and y's, and regraphed it, then you would create another function. And that's how these two relate to each other, okay? But just as an example, let me show you why you need logs. Okay, let's pretend that I asked you to do, 3 to some power is equal to 27. Okay. Well, if I ask you that, I hope everybody can do that, right? Because you can figure it out, because you're like, oh, well, okay, it's not x squared, or 3 squared, 3 squared would be 9, but if the x was 3, this totally checks out, right? So, like, that's easy. But if I gave you the same 3x here, and then I changed that to, like, a 40, well, there'd be an issue, there'd be a problem, because there is not an exact number here. Like, let's see, 3 to the third is 27. What's 3 to the fourth? 3 to the fourth, I think, is 81. 40 is somewhere between these two numbers, which means x is somewhere between 3 and 4. But you don't want to spend the next 10 minutes of your life playing guess and check in the calculator, okay? So this is why logs exist. Logs are a way of helping you get out of this situation and find out exactly, like, what is that exponent, okay? So I'm going to guess just for fun, and then we'll check it in the calculator later, okay? Let's guess. And you put a guess down too, okay? Somewhere between 3 and 4. 3 point what? I'm going to guess 3.24. That's my guess. I'm totally guessing. I may be way off. But anyways, I'm just going to do that. We'll check it later once we learn how to do logs and see if we did it right. All right, cool. So working in both worlds, the first thing you need to understand is how to rewrite this as a logarithm. So if you have a base and it's written up to some power, and it equals some value. So I basically recopied this just without numbers, okay? Then to rewrite it as a log is to do this. It's to change this into log base A of C equals B. So let's point this out. This A is a subscript. So whatever the base was here is now the subscript or the base of this log. And the B and the C here, they trade places. So notice there is no longer an exponent. There's a subscript, but there's not an exponent. This is just written like on a normal line, and this is written on a normal line. And with numbers, what that would mean for this problem that we just did here is it would mean that we would be rewriting it so that it was log of, okay, so what was the base in this problem? Well, the base was 3, so it goes there. The C is whatever's on the other side of the equals, so that would be a 40 written right there. And then on the other side of that would be the exponent. The exponent becomes what's over here. So this as a log is this. Please understand that these are synonymous. This is the same dang thing as this. They are just written in the two different worlds. One's written exponentially and one's written logarithmically. The answer to both is the same. Okay, and I'll show you how to solve these in just a bit. All right, rewriting exponentially. So if I gave you like log of, let's say you're given log 7 of, you know, I don't know, 49 equals x. Okay, so if you are given this and they tell you to rewrite it exponentially, then we work backwards. Okay, so these two, you could go back and forth, back and forth. So let's pay attention. The subscript of 7 that's here is the a, so it's the first thing that I write. Now the thing on the other side of the equals, this x, becomes our exponent. And whatever was the number next to the log base is what we equal now. So this 49 goes over here. So this is kind of what's meant by evaluate the logarithm, is sometimes once you rearrange it, then you can easily look at it and just do the problem in your head. Okay, so that's kind of how this works. If you're given one, you can always change to the other form and see if it makes sense. So you may see something like this, log base, Okay, this may be an evaluate the log question, log base 2 of 8. And somebody's just going to say, hey, without a calculator, figure that out. What is that without a calculator? Well, I always, even if it's not shown, I will write equals x. And then I use what I showed you back here to rewrite it. So the way I see it is this subscript is the first number I write. Whatever's on the other side of the equal is now the exponent. And the number next to the log base is what we are equal to. So it's like everything kind of rearranges. This one stays the same. These two switch places. And until you've practiced it a lot, guys, you're going to get mixed up the first 2 or 3 times. Just keep looking back at your model over here, and that's going to help you. Your model that I just destroyed with my pen, but whatever. Okay, so you're going to do this. And yes, technically you should be able to figure this out. Now, what I would notice is that I noticed that 8. Because 2 to the third is 8. But then I'm going to ask myself, what would possess the 8 to be in the denominator instead of the numerator? What could have possibly brought it down? Well, what about a negative exponent, guys? Because if you have a negative exponent, doesn't that just take this answer and move it to the denominator? So the answer to a problem like this is negative 1/3. Yes, it requires thought, and it requires an extensive knowledge of exponents so that you can figure out, oh gosh, is it going to be a negative exponent? Is it a positive exponent? Or is it even like potentially a fraction exponent? Those can get ugly. We will hopefully not see any of those in the homework, but if we do, I'll help you out. Okay, and let's practice. So solving using logs. All right, cool. So this is like that one from above. If it's 3 to some power is 12, I cannot do this in my head. Okay, so there's a couple of things or a couple of ways that you can do it. I'm going to show you probably what most of your teachers, well, I don't know. I don't want to say that. I'm just going to show you how I would teach my class to solve, okay? If I see this, then I would have them rewrite it, step 1. Okay, now if I rewrite it, I'm going to get log base what? Well, the 3's first, so the 3 is the subscript here, or the base. And these two switch places, so the number next to it's a 12. The exponent is now on the other side of the equals, okay? This is how my class would write it. Now, as far as analyzing this, like that's not something you're going to know in your head. In fact, you're going to need a calculator to do it. If you need to type this in, the way that this is typed in is using a formula, okay? It's called the change of base formula. You need this because if you've got a calculator right now and you hit, there is a log button, okay? But if you hit the log button, it's gonna look like this. And don't write this down. Please don't write this down. But if you hit log on your calculator right now, it does this. Now, notice there's nothing written down here. There's no base 3, and we need it to say base 3. Your calculator automatically does a base 10 every single time. So you can't just hit the log button. You need a formula. And the way that the change of base formula works is like this. Whatever these are, I'm going to write them as an A or a B. You can type it in as log of this other number over here over the log of the base. And now you can use a calculator. So with this problem, we're going to type it in as log of 12 divided by the log of 3, and that's how we type it in. So what I want you to do is make sure you close your parentheses, but grab a calculator and type log of 12 divided by log of 3, and it's giving me 2.26. This should make sense because if we come back up to the top, 3 squared is 9, and 3 to the third is 27, so we know it has to be somewhere between 2 and 3. So this does make sense, okay? So you got like another formula. I should have boxed that. That's just as important as the formula boxed up there, okay? You're going to be using both of these. All right, cool. So before we go and do these two, let's come back and check this one that we had earlier, the one that we typed in right here. Yeah. Remember how I guessed 3.24? Well, let's see how close I was. So here's our log base 3 of 40. So let's check that in the calculator. So in the calculator, I'm going to type in log of 40 divided by log of 3. And let me see what I get. Log 40 divided by log of 3. Oh man, I was off. Okay, it's 3.36. 3.36. So, oh well, I tried. Usually I'm a lot better at guessing them, but maybe I'm tired. Who knows? Okay, but we don't have to worry about guessing because we've got a calculator. All right, now we'll go and do one that looks to be a little trickier, but it's not going to be worse. I don't think it's going to be worse. Okay, now we've got this. Yay, what do we do with this? Okay, this is a mess. So here's what I would do. I would first clean this up as much as possible. And by cleaning it up, you want to try to isolate your exponent as much as possible. So in order to isolate this, I need to get rid of this -4. So I would start by dividing both sides by -4 just to simplify what we're dealing with. So what's 64 divided by -4? I think it's -16. Is that possible? Yeah, -16. Okay. And then what we would do is we would say 5 to some power is -16. Now, you should be scratching your head right now because I don't know about you, but I can't think of any kind of exponent that will turn my number into a negative number. That it's just not possible. Like, I'm already thinking, not possible. If you didn't notice that and you kept going, that's fine. Your calculator should tell you something. So let's see what the calculator tells us. If we try to do this problem, we'd be doing log base 5 of negative 16 is equal to x. And then we would pick up the calculator, so this is the rewrite, just like I did here. We'd pick up the calculator and we'd type this in as log of negative 16 over log of 5, and I'm thinking it's going to give us a nasty error message or something. I don't know. I hope y'all have a calculator. I should. If you're just like waiting on me to type it in, it's not nearly as much fun, so please be typing in with me. When I type this in, I get non-real answer. There you go, non-real answer. So even if you didn't notice that, your calculator will. Just don't wig out if you get that message. You know, if you're like, oh my gosh, the calculator messed up. No, probably not. You probably are fine. It's just a not possible type of a problem. Okay, so what about this? We're going to do the same thing. If we're trying to find y, you want to isolate that exponent as much as possible. So I'm going to start by adding 7 to both sides. And I'm going to get 11 to the y equals 27. Okay. Now, this is going to be 1 point something, okay? Because even if this was a 2, what's 11 squared? Like 121? Okay, that's way too big. So this is going to be like a 1.1 or something like that. So how do we figure out exactly what it is? Well, we're going to rewrite it. So if I rewrite, then it's going to be log base 11 of 27 equals y. So once again, just using that rewriting model and moving things to their new appropriate places. You can't type that in the calculator as is. You're going to have to do that formula for change of base. So log of the second number over log of the base. And then we'll type that in and see what we get. Okay, what do we get? Log of 27 divided by log of 11. 1.37. So once again, I was off. Okay, 1.37. But that's what we're getting. So that, everybody, is the awesomeness of logs. Now, there is way more involved, and we'll do a little bit more next week, in fact. But this is the intro just to show you, like, why do logs exist and what is their function. And this is their function. And in my mind, if somebody's like, why do we use logs? Like, I always think, I use logs so that that is possible. That's pretty much my number one answer every single time. And we'll continue next week, but you know, in the meantime, you got some practice problems, so see how those go, and we will see you in the solutions video.